Hello and welcome to the lesson on mapping diagrams. Mapping diagrams might be a new concept for you, maybe you've heard of it before. Let's see. So mapping diagrams are to do with sort of weird diagrams. Okay, so below are some examples of mapping diagrams. So they might not always be drawn as weird blobs like this, they might be drawn as kind of nice and neat looking shapes, like these ones for example, or they might be drawn like circles or ovals like that. In this case, they're kind of drawn like blobs. So below are some examples of mapping diagrams. Basically, the numbers on the left are the x values. And the x values are what we call the domain. So for a function, the values for a mapping diagram, the values on the left are the x values, which is part of the domain. The values on the right are the corresponding, what would they be? That's right, they would be the y values. There we go. For a function, that's these ones here. So the values on the right are the y values for a function. Remember, the y values are the range of the function. The domain are what are the x values that work with that function. The range is what are the y values that work with that function. Here's an example of another mapping diagram. We've got the x values here and y values on the right. There's another concept as well called, as you can see from these ones, I've got different kinds of concepts. There's another concept called one-to-one functions. So I've shown you an example of 3 different mapping diagrams that would correspond with 3 different functions. That would be a function, this would be a different function, that would be another function. And so what we're trying to point out is that you can have things called one-to-one functions. You can have functions that are not one-to-one functions. And so try to, from this, kind of like, and this one is not a function, for example. So a one-to-one function, what do you notice about the one-to-one function compared to the one that is not a one-to-one function? So you might have noticed something. So notice that the domain gets mapped onto the range. The domain x values get mapped onto the y values. So that's why they're called mapping diagrams. So did you notice that with the one-to-one function, that each x value corresponds to one y value? So we might want to type that up. Let's see. So we can make a little comment about that. We could say here, each x value is mapped onto or corresponds with one y value. So that's kind of like what we mean by a one-to-one function. Like that. A one-to-one function is one where for each x value there is only one corresponding value of y. That's what we mean by a one-to-one function. So notice that each x value corresponds with a y value. This one corresponds with a different y value. This x value corresponds with a different y value. As opposed to this x value corresponds to that y value, this x value corresponds to the same y value as the other x. So this is not a one-to-one function. So as in, so there are x values that correspond with the same y value, for example. So it's not like there's 3 separate lines connecting to their own little values. So this one is not one-to-one, and you might want to make a little note of why it's not one-to-one. So we could say various things. So we could say something like each not every x value has its own y value. That could be a reason for that one. So not every x value has its own y value because, for example, this x value shares a y value with this one. These two, they both share the same y value. This one has its own y value, but these two share what the y value. Okay, so, and this one here, it's not a function, y. It's also not a one-to-one function, and it's generally not a function. One of the main things that I wanted to say is, why is it not a one-to-one function? It's not a one-to-one function because there is an x value doesn't correspond to its own y value. This x value has got two separate y values. So this one is not even a function to begin with. And the reason why is, I'll just make a little note of that. Okay, let's make that a bit smaller again. So not a function to begin with. So there is at least one x value that maps onto, another word you can say is corresponds with, two different y values. So that means, to be honest, it's not even a function to begin with. So here, these are both examples of functions. This one is a one-to-one function. This one is a like many-to-one function. And this one is not even a function. Because a function, an x value can't have two different y values for it to be called a function. It's technically not called a function anymore if that's the case. Sound confusing? That's understandable. Okay, so here's some more examples. We've got m, which could be the mother function. This one, would you agree, is not one-to-one? Let's see, why is it not one-to-one? Have a think. So we've got how many different kids? 1, 2, 3, 4, 5, 6. So Joe and Samantha share a mother. Anna and Ian share a mother. Chelsea has her own mother. George has his own mother. And Sue doesn't seem to have any kids. So this mother function, this is the mother function, it's not one-to-one. And again, why? So why is it not one-to-one? Using a similar kind of concept. It's more like a many-to-one function. There are some x values which share the same y value. Not every x value, or not every child, corresponds or maps onto with its own y value. So by own is the operative word there. So not every x value, not every x value corresponds with its own y value. It's more like what we might call a many-to-one function, like many-to-one, many-to-one. There are some one-to-ones within it, but not every single one, not every one of these is one-to-one. So not all of these are only child. Some of them are siblings and they share a mother. So therefore it's not a one-to-one function. Whereas this one is one-to-one. For it to be considered one-to-one, every single x value must correspond with its own y value. So let's make a note of that. So this social security function, so remember, like in places like the US, for example, people have social security numbers. You might have heard recently, or some point in the news, about this big social security hack where people getting a hold of their social security numbers were being published online, which is not a great thing because that's the way everyone's got their own unique social security number that they can be identified with, like fingerprints. So Joe, he has a social security number. Samantha has a different one. Anna has a different one. It's not possible for two people to share the same social security number. So we can say this one is a one-to-one function. Let's put in a little message as to why. Because every x value corresponds to, or is mapped onto, its own y value. And the word every is important there, because as we said in the above one, there is an example where an x value has its own y value, but not every x value has its own y value. Like, for example, Joe and Samantha, they share a y value. Anna and Ian, they share a y value. Whereas in this one, every single x value is mapped onto its own y value. Is the function f below one-to-one? So you can see automatically, what would you say? No. Hopefully you said no. Because even though some of them map onto their own y value, like these ones, not every single one maps on, not every single x value maps onto its own y value. So let's write that. Doesn't seem to want to be smaller. Okay, not every x value maps is corresponds with its own y value. And it said, is the function below 1 to 1? So we could say no, as not. Groovy. Might seem like weird concept to you, and again, it's understandable. So here are some practice examples. So complete the following sets and mappings diagrams. So basically they want us to fill in any missing elements in the results here, in the sets, and then kind of state what things, like, you know, put your little arrows in. Because remember, in the mapping diagrams, you need to have the little arrows. Maybe something kind of like what we did here. Cool. Plus, on top of that, we're asked to and state whether the mapping is at 1 to 1. Is it many to 1? By many to 1, we mean kind of, for example, one like this, where there's many to 1. Or is it 1 to many? Like, you know, for example, maybe 2 back. 1 to many, so 1 to many. Or many to many. Okay, so anyway, first step, so just reminding us, this might be a kind of little thing you might want to put down, a nice formal definition. I'll just paste this in here because it's easy for me to paste like this. So what do we mean by a mapping? There we go. A mapping is used to map the members or elements of one set called the domain, so here's our domain, onto members of another set called the range. So if this is our domain, if these are the 3 x values, we need to calculate their corresponding y values. So we can do that easily. We can use the space below to work out the answers. So let's kind of do that here. So the first one, 2x minus 5. If x is negative 2, then we will have 2 times negative 2 minus 5. Subtract 5. What is that equal to? 2 times negative 2 is negative 4. Negative 4 minus 5 is negative 9. So you could, if you wanted to, then write negative 9 up here. So this one is negative 9. And let's continue where we were. Next one, when x is 0, then 2 times 0 minus 5. What's 2 times 0? 0 minus 5 is negative 5. Let's write that up here. Negative 5. Let's work out the next one. This might all seem so glaringly obvious. It's just a particular way to express a concept. So same thing, 2x minus 5 is our function. So 2 times 7, if x is 7, 2 times 7 minus 5 equals 14 minus 5. And what is that answer? That is positive 9. So notice that's different to negative 9, so that's a different number. If you ended up with the same answer, don't write that number twice, just instead you'll connect 2 things to the answer. So now let's finish up our mapping diagram. This number corresponds with that number there. This number corresponds with that number there. Could be straight lines, there's no need to do curvy ones. This number corresponds with that number there. Would you say this is a 1 to 1, many to 1, a 1 to many, or a 1 to many to many? You can see each member of the domain maps onto one member, its own individual member of the range. So we can say it is a 1 to 1. 1 to 1. Tend to use hyphens, don't we? So I'll do that. 1 to 1. Cool. The next one, question B, is rather interesting, so let's see why. Mapping the mapping is, it's not a function this time, it's not y equals 2x minus 5, it's just is not equal to. So would you agree 0, it is equal to 0, so we can't map it to that one. So we need to map 0 to 1, 0 to 2, 0 to 3. Perhaps I should get a little symbol, which is an arrow. That might be better. I want to do a nice straight arrow. There we go. Let's make it a nice colour. Green. Right, so 0 maps to this one. It also maps to this one. And it maps to this one. Continuing on, number 1. Number 1, let's do I'll just do a different coloured arrow just because it's going to start to look pretty muddled pretty soon. Number 1 is not equal to 1, but I mean it is equal to 1, so we can't map it to 1 because the function is not equal to this one here. So we can map it to the other ones. Next one, number 2. Number 2 is equal to 2, so let's not map it to 2. So let's map it up to 0, 1, and 3. Tiring? Yep. So now on to 3. 3, I'll do it with purple. 3 doesn't belong to 3 because the function is not equal to. So 0, 1, and 2. That's interesting. So would you agree that each x value maps onto multiple y values and each y value is mapped from multiple x values? Like the number 1 has been mapped onto 2, 0, and 3. So what kind of function do you think this would be? And out of these ones? And if you guessed many to many, you would be correct. So let's go many to many. Because a single x value maps onto multiple y values, and a single y value has been mapped onto from multiple x values. Many to many is correct. Next one along is mapping. We've got a function, this one. X equals y squared. Notice it's not y equals x squared. It's x. X is the ones on the left, the domain, equals y squared, the ones on the right, which is the range. So this number must be equal to something squared. So what squared would equal 0? You would be correct if you thought 0. There you go. So let's put a 0 there. So 0 corresponds with 0. Let's keep going. The number 1, x equals y squared. So would you agree 1 squared happens to equal 1? But don't forget something like negative 1 squared. Negative 1 squared is negative 1 times negative 1. It's also equal to 1. So we probably need to put negative 1 as well. So I'm going to run out of space. I'm just going to erase and do them a bit higher. So 0 for the first one. Make sure it's inside the set. So do it inside the circle. 1, negative 1 corresponds to these two. 4, what number squared, so what y value squared equals 4? You would be correct if you thought 2. Is there another y value? If you square it, it would come from 4. Yep, it could be negative 2. So we have completed that. Now what we need to do is connect them up with arrows. So the 0 only corresponds with this blue 0 here, but the number 1 corresponds with both of those red values. The number 4 corresponds with the 2 green values. Should use the lovely little arrow tool, shouldn't I? That would look a lot better. Okay, so we've mapped them. Now what we need to decide, is this a 1-to-1? Clearly it's not 1-to-1 because not all of the x values correspond with one y value. Is it many to 1? Doesn't seem to be. It's not like there's many things kind of going to 1, like 0 and 1 doesn't connect up to a single 1. This don't share 1. 1 and 4 don't share 1. 0 and 4 don't share 1. Is it 1 to many? It's not many to many, but yep, you would be correct in saying it's one to, sorry, it would be one to many. So let's write that out. It's a one to many. One to many. Here goes another one, D. D is asking, mapping is greater than. So this is greater than that. Do you think 0 is greater than 0? No, it's not. Is 0 greater than 1? No, it's not. Is 0 greater than 2? No, it's not. Is 0 greater than 3? No, it's not. So you would be correct in assuming that 0 doesn't connect up to this. 0 doesn't connect up to any of them. Because it's not it's greater than, it's equal to 0, but it's not greater than 0. Okay, the number 1 though. The number 1 does map onto some of them. Let's use our lovely coloured arrows now. The number 1, would you agree it's greater than 0? Is it greater than 1, 2, or 3? No, it's not. So that one's done. The number 2. Do you agree the number 2 is greater than 0? And it's also greater than 1. So the number 2 maps onto 2 different y values. The number 3. Would you agree number 3 is greater than 0, it's greater than 1, and it's greater than 2. So I think we've done our mapping diagram already for this. What we need to decide is this particular function, is it 1 to 1? Of course it's not. Is it many to 1? Not really, because it's not like any of these happen to share a y value. Is it 1 to many? Not always the case. It's a bit 1 to many, but even better, well, I would say it's many to many. Because notice that there are some that are 1 to many, that's fine, but there's also 0 happens to come from 3 of them as well. 1 connects to 2 of them. So I would say it's more many to many. This one is many to many. Compared with the one that was 1 to many, there weren't any at all that were many to many. So this was 1 to 1, but these ones were 1 to many. There weren't any of these that share an x value. But there were values of these that do share an x value, like 0 shares a 1, 2, and 3 from the x. Plus there's also some from this one that share a y value. So in that case, many to many tends to be the description in that case. And another question, E is kind of just drawn for you in a slightly different way. Rather than drawing the little blobs or the oblongs sets, they've kind of just drawn it on a number line instead. So the mapping is add 1. So notice the first one's been done from you, -2, add 1. So here's your x values, here's your y values down here. So feel free to write domain here if you want, write range there. So -2 add 1 is -1. We're going to continue doing some lovely arrows. -1 add 1 is 0. I want to use a nice colour just to make it a bit brighter so it stands out from the lines. -2 add 1 is 0. 0 add 1 is 1. 1 add 1 is 2. 2 add 1 is 3. 3 add 1 is 4. 4 add 1 is 5. 5 add 1 is 6. 6 add 1 is 7. And because there's no 8 here, I'm not going to map up the 7. And because there's no -3 here, this one stays blank too. So what kind of function is this? Is it 1 to 1? Is it many to 1? Is it 1 to many? Or is it many to many? I think you'd be correct in saying it's 1 to 1. So that's the end of this lesson on this kind of confusing and new idea called mapping functions.